Hey everyone, so I just wanted to go over a couple problems first, and then you will be able to try some on your own. So this is all about fair games and other applications of expected value. So in order to determine if we have a fair game, we always want to calculate the expected value, and that's what this section and this week is all about. So in most applications, an expected value of 0 has a certain meaning. So it depends the scenario what that means. So in business, it is the break even point. We're looking at a profit and a loss, right? So if it costs you $5 to make the lemonade, and then you're charging $6, then you're charging $4 for the lemonade, you're not really making any money, right? You haven't broken even with that expected value, so you'll need to reassess. In gaming, it means that the game is fair. So we want 0 as our expected value, or as close to 0 as we can. As close to 0 as we can get, that's the more fair games. Okay, so I'm just going to go through number 1 here with you. We're going to follow these directions. The rest of these you will try by yourself. Okay, so it says you are drawing a card from a deck of cards. You win $5 if an ace is drawn. You win $3 if a king, queen, or jack is drawn. You win nothing for a 10. If you draw a 9, 8, 7, or 6, you pay 75 cents. If you draw a 5, 4, 3, or 2, you win $1.50. So we're going to go ahead and answer these questions in the directions. It says create a probability table for the game looking at expected gains. Okay, so when we make our probability distribution table, this is what we looked at last week in week 30. We're going to have our what's expected, right, in terms of the money. Are we expected to gain $5? Are we expected to lose 75 cents? This is going to be our money that we are going to either gain or lose. And then obviously then we've got the probability. This is a dollar sign here. Okay, then we've got the money. So let's go through and read. So first of all, $5 if it's an ace. So expected to win $5. What's the probability? So how many aces are there? We've got 4 aces in a standard deck. Okay, the next one, you win $3. So expected to win $3 if a king, queen, or jack is drawn. So there's 3 different cards, king, queen, jack, for 4 suits. So we've got 12 out of 52 is the probability of pulling a king, queen, or jack. So we win nothing for a 10, so 0. And how many 10s are there? There are 4 10s. If you draw a 9, 8, 7, or 6, we pay 75 cents. So we are losing money there. So notice now it's not a gain, so I have a negative 75 cents. And 9, 8, 7, 6, there's 4 cards times 4 suits, so we've got 16 out of 52. And then if you draw a 5, 4, 3, or 2, we're paying $1.50, 4 cards, 4 suits, 16 out of 52. So remember last week we learned these probabilities all need to add up to 1, and so that is true. We've got 4 plus 12 is 16, plus another 4 is 20, plus 16 gives us 52. So we know our probability distribution table is correct. So that's part A, right? So part A is make the table. B, find the expected gain for the game. And in the video earlier in the instruction, we know how to find the expected gain. What we need to do is we need to multiply our money times the probability for each one of these. So 3 times 12 over 52 plus 0 times 4 out of 52 minus 75 cents times 16 over 52 minus $1.50 times 16 over 52. Okay, so if we do that, we get 0.38 cents. And that is our answer for part B. That's the expected gain. So on average, it's expected that you're going to win 38 cents. And then determine if the game is a fair game. Well, we're going to say the game is in favor of the players. Okay, so it is not fair. In order for it to be fair, we need it to be as close as possible to 0. I didn't want that to be a scribble. As close as possible to 0. Okay, so it's not incredibly fair. It's in favor of the players. The players are going to on average win 38 cents. If we got closer to 0, we know it's fair for the players and for the dealer or whoever's has the cards to begin with. Okay, we are going to check out one more different type of problem, and we're going to check out number 4. Okay, so sorry if there's some background noise right now. Okay, so the frequency table below was completed based on the history of the past 1,000 days at a car dealership. The table reports X, the number of cars sold per day at a dealer. Construct a probability distribution and find the expected number of cars sold per day. Okay, so when we make our probability distribution table, really we are just looking at our number of cars, this one and this one. Okay, remember the something with the money or how many cars are sold and the probability. That's what goes into our probability distribution table. This part right here is just helping us determine the probability. So number of cars sold, 0 cars were sold 44 on 44 of the days. Total days were 1,000. So the probability is 44 out of 1,000. That would be normally, like if you looked at our probability distribution table here, we have whatever we're looking at and the probability of that. So here we are looking at cars sold and the probability. I just need that other piece of information. So 1 car was sold on 87 out of 1,000 days. 2 cars were sold on 128 out of 1,000 days. 3 cars were sold on 234 out of 1,000 days. 4 cars, 297 out of 1,000. 5 cars, 155 out of 1,000. 30 out of 1,000. And 25 out of 1,000. Okay, again, if you add up all of our probabilities, we will get 1. So there's our probability distribution that we made, and now find the expected number of cars sold per day. So we will find our expected value here using the number of cars sold and the probability. So I'm going to have 0 times 44 out of 1,000 plus 1 times 87 out of 1,000 plus 2 times 128 over 1,000 plus 3 times 234 out of 1,000 plus 4 out of 297 out of 1,000 plus 5, 155 out of 1,000 plus 6, 30 out of 1,000 plus 7 times 25 1,000. And when we multiply all of that together, our expected number of cars sold per day is 3.363 cars per day. Okay, don't need to talk about fairness, it's not a game. Just on expected on average, they are looking to sell about 3.3 cars per day. Okay, so I hope this helps when you go complete some of these problems by yourself. Great job. Let me know if you've got any questions.